All right, absolute value functions. What we've done in the past with absolute value functions where we did the positive and negative case, okay, when we had one variable, it kind of changes what our graph looks like when we're dealing with two variables. Okay, if you think back to the one variable, we were just graphing on a number line. With two variables, so we have f of x, which is the same thing as what value? Y. Okay, if we have y equals the absolute value of x, or f of x equals the absolute value of x, you have two different variables that are changing. All right, we have some different parts of this graph that we need to identify in order to make sure that we understand what's going on today. The vertex is that point where the graph changes directions. Okay, and then these things right here I'm going to call branches. All right, so when you're dealing with absolute value of x, remember that when you put something inside your absolute value symbols, what happens to it? It becomes positive. If it's negative, it becomes positive. All right, so what I want to do is I want you to take a look at the sheet you picked up on the way in today. Okay, and on that sheet, I want you to go ahead and graph y equals the absolute value of x. Okay, use your table there, best you can. No calculators for this activity. All right, let's go ahead and talk about it. Your graph here, anyone want to tell me what they started with right here? Sarah? 1? Anyone start with something different? Yeah, Jill? -3. Anyone start with something different? Yeah? 0. Okay, I'm going to tell you I'm going to actually put 0 right here in the middle. Okay, now remember in this type of table, whatever y equals we put in right here, so that's absolute value of x, and so that means my input here is going to be 0, which gives me an output of 0. And that's going to build my table from there. Now if you didn't do it this way, that's okay. You don't have to erase everything. But I have a purpose for what I'm doing there. So there are all my inputs. And notice they all just output the same thing I actually inputted there. Okay, and then I've got my -1. Absolute value -1 is 1. Absolute value -2 is 2. And absolute value of -3 is 3. All right, now this point, 0, 0, got there. That's an ordered pair. This point, 1, 1. Oops, not 1, 0. 1, 1 is also an ordered pair. And 2, 2 is an ordered pair, and 3, 3 is an ordered pair. Now, if you please do me a favor and not work ahead on your paper, even though you may get everything right now, I'm going to give you some shortcuts and some, hopefully, easier ways to graph these. All right? So we have all of our ordered pairs. We plug them in, and we end up with that thing right there. Now, is this continuous data? Yes, it's continuous because it's an equation. Okay, and that equation is a function that I could put partial values for x in. If I put a half in, I get a half out. Okay, and so I can keep going there, and really it's important to make sure our line is accurate as we extend it. So if I put 10 in for x, the largest value on my graph, what would my output be? My output would also be 10. Okay, so I'm going to plot that point. So I have 1 at the very end to draw this branch to, and the same thing over here. I put -10 and I get negative or positive 10 out. So now I can anchor my line or that branch with that point up there so it doesn't extend in a weird direction. So if you're looking at your graph and you extended your branches all the way up and it doesn't hit 10, 10, that means you did something wrong. Your branch kind of straight off there. All right, how many got that? Okay. Now, why would I pick 0 and put it in the middle? What's significant about this point right here in the middle of my graph? Logan?
So you get the negative sign of your graph.
Okay, so I actually see both sides of the graph. That's important, for sure. What ensures me that I'm going to see both sides? Good answer there. What's this point called? That's our vertex. Okay, I always want to see your vertex right there in the middle. So the first thing you need to find is the vertex. That way, as Logan pointed out, you can see both sides of the graph. Otherwise, you don't see both sides. It's important that you're going to do this here. It's also important that you do that when we study quadratics here in a couple chapters. Okay, we have certain points I want you to find. That's one of them there. So if I'm looking at this one, this next graph, I want to find the vertex, and I want to put it right here, and I'm going to put a V right there. Okay? Go and tell your neighbor what the vertex is. So we got a guest speaker, Tom, today. Tom, do you know the vertex? Huh? Do you know the vertex of this one? 3 things up. So Tom says the vertex is right here. Everyone give Tom a hand. Well done, Tom. Tom is right. Good job, Tom.
Encore.
All right. Yeah, encore. Then I could go to lunch. Yeah. All right. So in order for us to easily find the vertex, we need to know vertex form. This is vertex form. G of x, remember G of x, same thing as y. Okay, G of x is equal to a times absolute value of x minus h, all plus k. This is a formula you should write down on top of your paper. In fact, I'll let you write it down here. So as you progress in math this year, we're going to study multiple different patterns. Good. We're going to study multiple different patterns. And when you get to Algebra 2, you're going to increase that. So all those families of functions that are on my window up there, if you go out, when you go outside and look, there's like 14 or 13 of them. You're going to study all those in Algebra 2. This year, you'll study 4 or 5 of them. Okay, you've already studied linear. We're going to do absolute value and quadratic. Every one of those has an HK shift. H and K of some sort. And we have an A there. Yeah. It's your junior year. It's second year algebra after you do geometry. Yeah, very fun. I know. No, let's talk about that later. Okay, vertex of a graph is...
Numbers.
The vertex of our graph is found by setting this part inside equal to 0. Now, the book will actually say, hey, it says the vertex is HK, which it is. It's HK, but it's really important that we understand that really our H value it has to be in this form in order for H to appear. Okay, so let me give you an example. What's my H value? What's my...
3.
Now, what's my H value? Okay, some of you aren't participating. Tell your neighbor what the H value is.
-3.
Yeah. All right. Quentin, what's the H value?
-3.
The H value, Quentin says, is -3. How many agree? How many disagree? What is the H value? It's not -3. It's close.
3.
Yes? It is +3. Your H is right back here. Okay, notice it says x minus. Okay, so x minus, it's the piece after the minus. It's 3. Okay, it's not -3, it's +3. What's your k value?
2.
It's 2. It's the piece out there. So 3, 2. That is my vertex. Okay, stop. That is my vertex. It's HK. All right? How many are with me? Okay, let's give you another one to try. If I give you y equals... Hold on a second, Sarah. Okay, tell your neighbor the vertex. Okay, put them away. We have silly rules when we do silly things. Okay? All right. Volunteer, what's the vertex? Kellen? 21, -7. Okay? That's 21, -7. Very good. Sarah, question? Nope. Can we keep going? Let me keep going. All right? Here's another one. Okay. Write down the vertex on your paper. Okay, tell your neighbor what you got.
4. 4, -3. My neighbors.
Jonathan, what's the H term? 4 and K? -3. I'll agree with one of those. Okay. Jillian, which one do I agree with? I agree with this one. This one is correct. Okay. Mercedes? It would be -4. Now it's -4 because in order for us to get a minus there, it'd have to be x minus -4. Right? Two negatives make a positive. Okay? So that kind of becomes a little confusing. So for that reason and for the reason on this next problem, I have you do it a bit differently. Okay? Go and tell your neighbor the vertex.
4, 2. 4, 2, 4, 2.
Good job.
Those 2 digits make my favorite number, actually.
Nice. Impressive, Quentin. All right. Quentin's going to give us the answer. Go ahead, Quentin.
4, 2.
4, 2. How many got 4, 2? Okay. Now, this is where the HK thing that they talk about up here is a little tougher if you really don't understand what they're saying. It has to be in the format of 1x minus h. There's nothing in front of that x. When there is something in front of the x, then you have to get rid of that something. Or, better yet, what I teach my Algebra 2 students and what I like to teach the algebra students when we introduce this is anytime you're solving these, if you really want to find your h value of your vertex, we call that, the h means our x value there, okay, of our vertex. What we do is we just set that equal to 0. What will make that equal 0? Well, there's 2 steps. What are the 2 steps?
Solve for 3x minus 12.
Okay, we add 12, and then we divide by 3. So x is 4. That is the h value of your vertex. Okay? And this is still 2. All right, now notice that will work on all these. Right here, what makes that equal 0? Hold on. X plus 4 equals 0. What's x? It's not 4. 4 plus 4 is 8. It's -4. Right? What makes this 0? 21 is 21 minus 21 is 0. So 21 works. What makes this 0? +3. Okay? So if I give you this one, well, actually, let's go on to our notes here. This one right here, what makes this 0? 2. This is on your note page, right? 2. So that means the x value of our vertex, if I put it in the middle down here, is 2. What's our k term? 0. There's nothing out here. So it's just like a +0 at the end. That is our vertex. That means my graph changes directions at 2, 0. I can put a point right there. I know my graph is going to be symmetrical, meaning it's going to be a reflection about this line right here. Just like on this one, it reflected. Like all these points over here reflected to those across this line. Called our axis of symmetry. Okay? Same thing happens here. Everything's going to reflect across this line. So if I find this point, then I know this point is 1. And if I find this point, I look in the mirror and it's 2 away, so this one is 1. Everyone get that? In fact, we can test to make sure those points are accurate by plugging them in down here for x. We can say, well, if x is, this is 2, let's just pick the next value. That's 3. When I do the math, 3 minus 2 is what? 1. And absolute value of 1 is? 1. Okay? And if I put 4 in, well, 4 minus 2 is? 2. And the absolute value of 2 is? 2. Okay, so we get 2. 2. All right. Everyone rate themselves 1 to 5 right now. Okay. What kind of questions we got? Sarah. So right here, when I was picking values, I'm just picking value. I found my vertex and I'm picking numbers on this, on one side of my vertex. So the other side, here's 2, so I could pick 1. If I pick 1, that's my x, that's an input. I'm putting that in for x. 1 minus 2 is 1, and the absolute value of 1 is 1. So my output is 1. So you're just picking the values. The next one would be 0. I put 0 in. 0 minus 2 is negative 2. Absolute value of negative 2 is 2. So you're just doing input output. Okay, tell your neighbor what the slope of this line is right here.
1 over 1.
All right, Vincent, what's the slope of that line right there? How much do I rise? 1. How much do I run? How much? I can't hear. 1. So up 1 over 1, what's that slope? 1. So slope is 1. Okay? Tell your neighbor what the slope of this line is right here.
1. 1 over 1.
All right, Sebastian, what do you think? It is not 1.
1 over 1.
It is negative 1. Okay? So it's negative 1 because it's going down and then it's 1 coming out, right? It's a reflection, right? Everything's kind of backwards in a mirror. Correct? Okay? Same thing here. So like if you write study on top of your forehead, so you remember to study, and then you look in a mirror, you're like, huh?
That's why you have to write it looking in the mirror.
All right.
I don't know how you can write it not looking.
Yeah, I don't know. All right. Hey, you guys, it's reversed. So it's a slope coming in and a slope coming out. All right. I will tell you that that 1 appears somewhere in our vertex form. What's the one variable we haven't dealt with in vertex form?
A.
That's our A. Our 1 is sitting right there. So what's A in this one?
1.
1. What's A in this one?
1.
A here. A here.
1.
All of those mean that is your slope. This is your slope and its reflection, right? That deals with a vertical, it's called a vertical stretch or shrink. A is the slope in this. We call it a vertical stretch or shrink.
Can I get used to that?
X. I would never ask for the slope on it. I would ask for what's the vertical stretch or shrink. Okay? And so if I looked at this and said, what's the vertical stretch of this? You'd say you'd say A is 1, which means it doesn't have a vertical stretch because everything starts at 1. From there, we stretch or shrink. Okay? So like on this one, do I have a vertical stretch or shrink? No, because it's 1. Which means when I find my vertex, go ahead and write your vertex down for that one. All right, Zach, what do you got for a vertex here? 3? Which one's 3? X or Y? X? Y? Dude, we got both of them covered. How many say X? How many say Y? All right, we'll go with Y. Yes, it's 3. What's inside here? What makes this 0? 0. Okay, and then there's our K, 3. All right, what's our slope, Gunner? What's our A term? No, what's our A term? It's 1. That means from here we go over 1 and up 1. Over 1 and up 1. Over 1 and up 1. So Sarah, you were confused a minute ago when I was throwing all those values into my table. Well, if you know the pattern, if you know how to use that A term correctly, then you don't have to calculate the table every time. You could actually graph it first, reflect your points, and then you get both sides of your graph, and then you could fill out your table. It's kind of backwards. But your table, you at least see the pattern in your table and be able to make predictions off it. And you'd have your graph as well. So if I do that, notice my table isn't filled out yet. Well, put some values. There's 1. What was 1? We'll go 1, and it's? Yeah, it's 4. When x is 1, g of x is 4. Okay, when x is 2, g of x is 5. When x is negative 1, g of x is 4. And when x is negative 2, g of x is 5. Notice it's symmetrical in your table as well. All right, now we're spending a lot of time on graphs that seem pretty easy. Logan? Always be completely symmetrical. Yeah, it reflects across. All right, let's move over to the next side to make it a little more complex for you. All right. Let's put our vertex right here. Everyone write down the vertex without looking at your neighbor's paper, please.
Did we flip the sheet over?
Yeah, we did. All right. So, remember the vertex, the x value is whatever makes the inside equal to 0. What makes the inside equal to 0? 0. What's being added to the outside? 0. Our vertex is 0, 0. How boring. Okay? What's my A term?
2.
Yeah? 2. So, let's see. Who wants to pick? Oh, Jason. What do you think, man? Is this a vertical stretch or shrink? I know it's vertical, so it's one or the other. Stretch or shrink. No, it's 50-50, dude. You don't know. That's all right. Just pick one. Stretch. Why did you say stretch? Huh? Because Max said it? All right. Well, dude. Matt, why did you say stretch? Sarah? No. Yep. That won't matter, though. When one was positive. Cassie? Good, because it's greater than 1. It's a stretch. Okay? I know, you should have said that. Okay? It's a stretch because it's greater than 1. So when A is greater than 1, we call it a vertical stretch. Important term. We'll use it this year. You'll see it on your test, or you'll have to write it on your test. It's a vertical stretch when A is greater than 1. If it's equal to 1, it's not stretching or shrinking. Right? But if it's less than 1, we call it a
Shrink.
Yeah, we call it a vertical shrink. Now, the reason I keep calling it vertical is because we also have horizontal stretches and shrinks. They happen inside. And we're not going to cover those right now. But we're going vertical, stretch, and shrink. Yes? No, if A was equal to 0, so that's a good question. So it has to be less than 1, but it has to be greater than 0. So good point. Yeah, A has to be greater than 0. Because if you get to 0, we put a 0 out here, what happens to this?
It immediately bounces up. No, nothing happens.
Come on, speaking the language of math. If I put 0 out here, what happens?
Nothing. It just flatlines.
Yeah, you get x equals 0. Okay? All right. No, you get q of x equals 0. X, yeah, or k, if k is there. If we get a k term. Good job. All right, Brady. What's my slope here? 2. So from this point I go up 2 and over 1. Up 2 and over 1. Okay, now what do I do with those points, Isaiah? What do I do with these points? Huh? Connect them? All right, we connect them. Before I connect them, what am I going to do with them?
Eat them.
Mirror them.
Yeah, I got to mirror them. I got to reflect them. I got to move them over here. Right?
They look just happy right there.
You reflect them over the axis of symmetry. Now I messed this one up. Look, this one's 1, 2, 3 away, 1, 2, 3 away. Unbelievable. Such a rookie mistake. And then, Mac, what do I do?
You
Grab a ruler and I connect them. Only because Mac said so. All right. I think you got it. Okay, very good. Let's see if you get the challenge problem there. Not really a challenge, but it should be a bit of a challenge. Go ahead and work on it with your groupie. Anyone want to tell me what happened? Raise your hand, please. No, not enough people. Okay, that's fine. No, we won't do it that way. That's kind of boring. Okay, I need 15 of you. What happens? Oh, you got, like, what happens with the graph? Huh? Oh, raise your hand, man. Don't ruin the end of the movie. We have 10, we have 11, we have 12. 13. Very good. All right. Sergi, what'd you get happen? You don't understand? Okay, what's your vertex? Mac, not appropriate. What's your vertex? Nope. What's inside here? What makes that 0 is 0. So our vertex starts with 0 on X. What's on the outside? What's on the outside out here?
-1.
Hey, will you guys be quiet? Yeah, it's 0. So our vertex is 0, 0. First thing you need to write down is your vertex every time. The A term helps us once we have the vertex. Okay, so the A term. Elizabeth, what happens? I'm sorry, Lexi. Sorry. Lexi, what happens? What's your sister's name? Yeah, what's your sister's name? Yeah. So everyone's like wondering why I called her Elizabeth. There you go. I have her sister in my other class. All right, Lexi. What happens? Okay, so what's your next point? Give me a coordinate. 1, negative what? -1/2, and then 2 what? 2, is it 2 positive 1? 2 -1, okay. Anyone else get that point right there? Yes. Okay. Hey, I like that point. What happened? I dropped down 1 and I ran over 2. Go down 1 and over 2. Down 1 and over 2. So our slope, right? Rise -1, run 2. And then you reflect it.
Or yellow.
That one's wrong. No, that one's right. All right. Okay, last thing to do. In your notes, I want you to summarize what a negative sign does on your A term. In your notes, summarize what a negative sign does to your A term. All right, Desha, what does a negative sign do to the A term? Christina, what's the negative sign do to the A term? What's the negative sign do to the A term? What's it do to your graph when you put a negative on the A term? Good. It flips it over. It reflects it in the y-axis, or excuse me, the x-axis. Okay? So make sure you note that a negative A reflects the graph in the x-axis. For some of you, you may just write it opens down.
Becomes more like an
Okay? It reflects the graph in the x-axis. That's mathematically what we say. It opens down. Okay? All right. Very good. Guys, Question came up, do I have to fill in that table? The answer is yes, you still have to fill in the table. If you're given a table, fill in the table. It's up to you what order you go. If you want to fill in the table and then graph it, go for it. If you want to graph it and then fill in the table, that's fine as well. Just make sure that the points coordinate. If you've graphed it first and then you fill in the table, I'd be fine if you just write 1, 2, 2, 4, 3, 6. Okay? You don't have to fill in the middle part then. That's just to show your work. All right? But if you're not having to show your work, then you're good. Okay, your assignment, you got 1 through 4 on the front, and then you have 5 through 8 on the back. Okay? Notice those A shifts. Make sure you ask some questions. If you need help, identify the vertex in your table, please.